This is section 4.2, so let's get started. Zero and negative integer exponents. So in this section, we will continue to discuss the rules of exponents. Recall that exponents are used to indicate repeated multiplication by the same number, called the base. You can see what our objectives are for this section. We're going to deal with exponents of 0. We're going to deal with negative integer exponents and exponent variables. Okay, so first, let's look at 2 to the third power divided by 2 to the third power. Well, 2 to the third power equals 8, right? So 8 divided by 8 equals 1. Pretty simple. Anything divided by itself is 1. But I want you to look at it in another way because you know the rules of exponents now. You can see that we have the same base. What is our base here? It is 2. Since we're dividing and we have the same base, we can use our rules for exponents, which is we can subtract the exponents. 3 minus 3 is 0. So on this side, we receive the answer of 1. And on this side, we receive 2 to the 0 power. So this proves to us that 2 to the 0 is also equivalent to 1. Let's look at x to the third over x to the third. Again, anything divided by itself equals 1, so we know that this equals 1. But if you look at it as x to the third over x to the third, we have the same base again. So this is the same exact situation as before. We subtract the exponents again. 3 minus 3. So it doesn't matter, notice, because we have x to the 0. It doesn't matter what's in this position. X represents some number, right? So if it's any number other than 0, if it's to the 0 power, then that proves to us that it equals 1. So that takes us to our next rule that we should know. Any non-zero number with an exponent of 0 is equivalent to 1. So here, a to the 0 power equals 1. Remember that rule. So let's go to the next problem. We have 5x. Notice it. 5 and x are in parentheses. All of it's to the 0 power. Therefore, the answer to this equals 1. Let's go to the right. Negative 3x plus 7 to the 0 power. Again, all of this is to the 0 power. Therefore, it equals 1 again. Now, the next problem is not the same. Can you tell me why? Well, notice everything is not inside the parentheses. Therefore, everything is not to the 0 power. What is to the 0 power? Only the x is to the 0 power, not the 3. The 3 is actually to the first power, right? So what you really have is 3 times x to the 0, which equals 3 times 1, which equals 3. So the answer is not 1 for that particular problem. Let's move on. Negative 3 to the 0. So what is to the 0 power? 3, not the negative. So tip to remember, let's go down here. An exponent applies to only the factor it is directly next to. So this right here, negative 3 to the 0, is really the same as negative 1 times 3 to the 0. Wouldn't you agree that what's on the left side is equivalent to what's on the right side of that equal sign? This is the same as this. Therefore, we have negative 1 times 3 to the 0 is also 1. But negative 1 times 1 is negative 1. Let's move on to the next problem. We have an 8. Again, 8 is not to the 0 power. Times, we have an x to the 0, which equals 1, plus, and we have 5. So we have 8 plus 5, which is 13. Now let's go to the next problem. We have 6x to the 5th times 3x to the 5th times x to the 0. Well, we know that x to the 0 equals 1, so we don't really have to worry about that too much, right? Because anything times 1 is itself. But there is a rule for this. When you're multiplying, we can multiply 6 times 3. That's pretty simple. That's 18. But what is the rule for x to the 5th times x to the 5th? Same base, so we add the exponents, which would give us 18x to the 10th power. Let's move on. Let's take a look at the following examples. We have 6 to the 2nd divided by 6 to the 5th. Now we know that we can simplify this by the two ways. 6 to the 2nd is 36 divided by 6 to the 5th. Put that in your calculator. It would be 7,776. Then that can be reduced because 36 can divide into 7776. 36 goes in itself one time. 36 divides into 7,776 216 times. Now, if we had done it the other way using our rules of exponents, we see that 6 to the 2nd over 6 to the 5th involves the same base. We're dividing. Therefore, we do what to the exponents? We subtract them. So it becomes 6 to the 2 minus 5, which is 6 to the negative 3. Now, we basically just worked this problem out in another way, but notice our answers do not look alike. So, are we saying that 6 to the negative 3 is 1 over 216? Is it the same? Well, actually it is, because 216 happens to be 6 to the 3rd power. So really, what we want to emphasize for this particular problem is that 1 over 6 to the 3rd is equivalent to 6 to the negative 3. These are equivalent to each other. Now, it's conventional or customary that we write our answer, write final answers with positive exponents. So always write your answer with positive exponents. Positive exponents. So really, we would like to change 6 to the negative 3 to 1 over 6 cubed. So basically, to change the sign of your exponent, you will move the position of your base to the denominator in this case because it's originally in the numerator. So if you switch from numerator to denominator, you must change the sign of your exponent. And again, the rule is always write your final answers with positive exponents. So here we have this rule, x to the negative n equals 1 over x to the n, and x to the n, if we took this to the denominator, it would be 1 over x to the negative n. If we took this to the numerator, we would change the exponent, the sign of the exponent again, and it would be x to the negative n. So these are some rules you also need to learn. But let's go over some practice problems so that you can learn the rule a little better. All right, next we have 2 to the negative 4. So the first thing you should do when you have a negative exponent is to make that exponent positive. As you can see here, it's considered to be 2 over 1. 2 to the negative 4 over 1 right now. So this is in the numerator. This is considered to be in the numerator. To change the sign of that exponent, we're going to drop it. All right, we're going to drop it to the denominator. All right, therefore, if we drop it to the denominator, it changes the sign of the exponent. So the sign becomes positive 4 now. But what's in the numerator? We took everything from the numerator. What is understood to be in the numerator? It's always understood to be a 1 because 1 times anything is itself. Just like this is understood, this 2 to the negative 4 is considered to be 1 times 2 to the negative 4. All right, we are not done. Can you tell me why? Well, because we're dealing with regular numbers, we can figure out what 2 to the 4th is in the calculator, right? So again, in your calculator, you probably need to use the y to the x functionality. So in your calculator, 2 to the y to the x or x to the y, or you could use that little cursor again. So 2 to the 4th is 2 times 2 times 2 times 2. So we should get 16. Next, we have y to the negative 7. All right, this y is a variable, but we're going to treat this the same way. The rule is always write your final answers with positive exponents. So the only thing we have to do for this particular problem is ensure that our exponent is positive. So what is y to the negative 7? This is basically the rule we're using right here. What is y to the negative 7 equivalent to? 1 over y to the positive 7. Next, we have negative 3 to the negative 3 power. So notice all of this is inside of parentheses. One thing you could do is go ahead and drop all of this to the denominator. But what happens to your exponent? It's no longer negative 3. It's positive 3, right? And there's an understood 1 in the numerator. We are not done because negative 3 to the 3rd power means negative 3 times negative 3 times another negative 3, which is negative 27. Now, only thing left to do is move that negative to the side of your fraction or in the numerator. So it's customary to move negatives up. So either this way, or you could have written it negative 1 over 27, completely in the numerator or on the side of that line, that fraction line. All right, next we have 2 to the x to the negative 2. Here's my question for you. What is to the negative 2? What specifically is to the negative 2 power? Only the x is to the negative 2 power, not the 2. Only the x is to the negative 2 power. Therefore, really, the only thing that we want to move to the denominator is the x, right? The 2 will remain in the numerator, and we're going to take that x to the denominator and change the sign of the exponent. Some will look at it as 2. All right, some people will look at this as 2 times x to the negative 2, which is 2 times 1 over x squared, which is also 2 over x squared. So however you decide to do it, you will still end up getting 2 over x squared. Next, let's look at 1 over 3x to the negative 2. Notice that 3 and x are both to the negative 2 power. Since this is originally, which is interesting, in the denominator, in order to make this a positive exponent, we're going to move it to the numerator, right? So it becomes 3x to the positive 2 is now in the numerator. Now, yes, it is understood that there's a 1 in the denominator, but there's no need to write that 1 in this particular case in the denominator because it's understood to be there. Any number is always understood to be divided by 1. Now, we need to keep going. What does this mean? So these are the rules you learned from the last section. So this is 3 to the second times x to the second. Therefore, the final answer is what? 9x squared. Let's move on to this problem. Negative 5x to the negative 3. So again, let's test you. What is to the negative third power? Is it negative 5x? Is it x? Or is it negative 5? If you said only x, you are correct. So the only thing we will move to the denominator is the x. So it becomes negative 5 divided by x cubed, or that negative on the left side of that fraction bar. These are both acceptable. Just never leave the negative in the denominator. So let's go over some rules you need to learn as soon as possible. These are a combination of the rules that you learned from the last section and this section. First, the rule a to the m times a to the n. Notice we have the same base. So what is this equivalent to? I'm going to let you think about it. You might want to pause before I give you the answer to ensure that you understand, you have memorized these rules. It is a to the m plus n. Second rule you need to learn. What about a to the m divided by a to the n? What is that equal to? If you said a to the m minus n, you are right. Next, what about a to the m power to the nth power? What is that equal to? If you said a to the m times n, you are correct. Next, what about a, b, in parentheses, all to the nth power? What is this equivalent to? If you said a to the nth times b to the nth, you are correct because everything in that parenthesis should be taken to the nth power. Next, what is a divided by b all to the nth power equivalent to? If you said a to the nth divided by b to the nth, you are correct. What about a to the 0? What does a to the 0 power equal? If you said 1, you are on track. What about a to the negative n? What would you say a to the negative n is equivalent to? If you said 1 over a to the positive nth power, you are correct. Lastly, what if I gave you a over b to the negative nth power? Could you figure out what you needed to do here? So pause the video, see if you can work this out using all of the rules we discussed, and once you get your final answer, you can press play. So first, what I would do is I would use the rule from number 5 here. First, I would write a to the negative nth over b to the negative nth. But here, the issue is that we must follow this rule from 7, right? That we do not want any negative exponents in our final answer. So what are we going to have to do to get rid of these negative exponents? Well, what you could do is basically flip everything here. So the reciprocal of this, because you can take the a to the denominator and take the b to the numerator. Therefore, your final answer would be b to the nth over a to the nth power. Let's move on with some final examples. Let's practice all of the rules together. X to the 7th times x to the negative 9. Well, we are multiplying. We have the same base, so we're going to add the exponents. But when we're using our integer rules, we notice that ultimately we're going to have to subtract that. So that becomes negative 2. We have a negative exponent. Therefore, we will rewrite this as 1 over x squared. Next, we have 7xy to the negative 2, all to the negative 2. We can do this in a couple of ways. One way is you can take all of this to the denominator. For example, 1 over 7xy to the negative 2 to the positive 2. Right? It changes this exponent. Then you can multiply through everything in this parenthesis. Take it to the second power. So we have 7 squared, x squared, and y to the negative 4 because of negative 2 times 2. Now we have 1 over, we have 49. However, what I'm going to go ahead and do is move that y up, right? So it'll be y to the 4th in the numerator. We have 49 in the denominator as well as x squared. Or we could have treated this problem a little differently. We could have, from this point here, from the beginning, we could have taking -2 to everything inside that parenthesis. So that would be 7 to the -2, x to the -2, y to the +4. We could have done that, but of course we can't leave it that way. Then we notice that the only thing that stays in the numerator is y to the 4th, so I'll rewrite that in the numerator. 7 to the 2nd will move to the denominator, and x to the 2nd will move to the denominator. And as you can see, we still end up with y to the 4th over 49x squared, which is the same answer. Next, let's move on to this problem here. We have 3 to the 3rd. If you want to go ahead and take everything to the 3rd power, a to the -12th power over, and so don't forget the denominator as well, b to the 21 power. Now, 3 to the 3rd power is 3 times 3 times 3, which is 27. But what we're going to do is let's move this to the denominator, right? So I'm going to put it in the front since it's a becomes before b. So a to the 12, b to the 21. So 27 over a to the 12, b to the 21 power. Next, we have this problem. Let's take everything on the inside to the -2 power. So that would be 6 to the -2, x to the 12th power, y to the 14th power, 0 to the z to the 0 power. Now we already know that that equals 1. So we don't have to worry about that because whatever we get is being multiplied times 1. Now notice that x and y have positive exponents. They will remain in the numerator while we move 6 to the 2nd to the denominator. So our final answer would be x to the 12th, y to the 14th over 36. Next, let's take everything on the inside of this parenthesis to the -6 power. So that would be a to the what? A to the 12th, b to the 30th, over c to the 66. Now, actually, we can't do anything else. These are not the same bases, so we can't subtract the exponents or add the exponents. Moving on to the next one. Notice that we can reduce -2 over -8. What is negative divided by negative? So our answer will be positive. Let me point out that these are not exponents. These are signs in front of numbers. So we're going to have 4 in the denominator, because 2 goes into 8 4 times. We have x to the 4 minus 7. We have y to the -4 minus 3. So x to the -3, y to the -7 over 4. Since our exponents are negative, we need to move them to the denominator with the 4. So in the denominator we have 4x cubed y to the 7. What is remaining in the numerator? If you said 1, you are correct. The last problem. What operation do you think this problem is? It is definitely multiplication, because we have 5x squared y right next to this parenthesis. What we can do is multiply the whole numbers together. We got 5 times 2. That's 10. we have x squared times x to the 4th power. So that's x squared. We have x to the 2 plus 4, right? Because we're multiplying variables with the same base. So we add the exponents. We also have y and y to the negative 3. So y is to what exponent? 1 plus a negative 3. So we have 10 x to the 6 because 2 plus 4 is 6. And we also have y to the negative 2. Now what should we move? We should move the y to the negative 2 to the denominator. So the final answer would be 10 x to the 6 over y squared. Well, that concludes the video on 4.2. If you have questions, either put those questions in the problem solver form. If you're an online student, if you're a ground student, you can always ask me questions in class. Until the next time.